Have you ever wanted to buy a product, but there are more than 1,000 reviews, and you didn't want to spend your afternoon reading all of that? You just wanted one thing, a clear summary of what people think and how they really feel about it. And you find in the same page an AI-generated summary that gives you the overall sentiment. How does this actually work? How can AI read hundreds or thousands of reviews, understand the key point, figure out the overall sentiment, and summarize everything into one simple text? If you are wondering that, you are in the right place. Hi, I'm Sarah Alali, a senior technical trainer at Microsoft, specializing in AI, Copilot, and building intelligent and secure applications on Microsoft Azure. I have a PhD in computer science and 12 years teaching training experience. This course covers 12 sessions, where we will dive into core AI concepts in Azure and learn how to turn ideas into real applications using modern tools like Microsoft Foundry. In the 5th session, we will cover an introduction to natural language processing concepts. I will walk you through how natural language processing helps machines understand and analyze text. Let's start by understanding what is natural language processing, often called NLP. In simple terms, natural language processing is how computers understand and extract meaning from text written by humans. Humans read text and instantly understand what it is about. For computers, that's not natural, and NLP is how we make it possible. Let's start with a simple example. We will use this short paragraph from the slide as an example to understand how NLP analyzes text. Alex and I attended a Microsoft AI conference. It was in Las Vegas on September 21st. It was a great opportunity to see the latest technology. The advances in AI technology are amazing. It is very exciting. Now let's understand how NLP can analyze this simple text in different ways, depending on the task. NLP can help us do key term extraction. Key term extraction identifies the most important words and phrases. So, from this paragraph, key terms may be Microsoft AI conference, AI technology, latest technology, and so on. Now, why do we need key term extraction? Organizations use key term extraction to index documents for search, to identify main topic, and to quickly understand what large volumes of text are about. NLP can also help us get named entity recognition, or NER. This identifies real-world entities. From the same text, NLP can detect people, like Alex, organization, which is Microsoft, event, that is AI conference, location, Las Vegas, and date, September 21st. We need these name entities to redact personal information, extract structured data from documents, and support compliance and reporting scenarios. NLP can help us also get sentiment analysis that determines the emotional tone of the text. In this case, the sentiment would clearly be positive. Words like amazing, very exciting strongly indicate enthusiasm. Now, organizations use sentiment analysis for social media monitoring, customer feedback analysis, and measuring satisfaction and brand perception. NLP can help us also with text classification. These assign the text to one or more categories. This paragraph could be classified, for example, as technology, AI and innovation, or maybe conference or event recap. Text classification is a powerful tool for spam filtering in emails, categorizing articles on website and news feeds, and also automatically routing support tickets to the right team. We have another important usage of NLP that we are all using nowadays with Copilot, which is text summarization. This shortens text while keeping the key messages. A summary of this paragraph could be, for example, Alex attended a Microsoft AI conference in Las Vegas where exciting new advances in AI technology were presented. Summarization helps with quickly reviewing long documents, creating executive briefs, or reducing reading time while keeping the context. As you can notice, the same paragraph produces different insights depending on the NLP task you apply. Key terms show topics. Entities show who, where, and when. Sentiment shows how people feel. And classification shows what category it belongs to. Finally, summarization shows the core message. Now, how NLP is used in real business scenarios. These NLP tasks support real-world use cases. For example, search indexing for document and website, personally identifiable information redaction to protect sensitive data, chatbots and virtual assistant that understand user intent, spam filtering in email system, content categorization for articles, feeds, and blogs. The good news is Azure Language Services automate these NLP tasks. You don't need deep linguistic or data science expertise. You simply call ready-to-use APIs and get structured insight from text. Now let's focus on a step that happens before any analysis takes place by NLP, which is text preprocessing. Text preprocessing is all about preparing raw text so machines can analyze it effectively. Humans can read messy, unstructured text without thinking about it, but computers can't. They need the text cleaned, simplified, and structured before they can work with it. To make this easier to understand, let's use a famous example from history. We choose to go to the moon. Even though this sentence feels simple to us, a computer has to process it step by step. The first step is tokenization. Tokenization means breaking text into smaller pieces called tokens. For simplicity, you can think of each word as a token. So instead of seeing a full sentence, the computer now sees individual pieces. We choose to go to the moon. At this point, the sentence becomes a list the system can analyze. Next comes normalization. Normalization means cleaning up the text by removing punctuation and turning all letters into lowercase. After normalization, the system often removes stop words. Stop words are very common words such as the, it, or to. These words make sentence easier to read for humans, but they usually don't add much meaning. Once stop words are removed, the sentence becomes much simpler, leaving words like choose, go, and moon. This helps the model focus on what really matters. Another important step is stemming or lemmatization. This is about grouping related words together. For example, words like power, powered, and powerful are all connected and describe the same idea. Stemming and lemmatization reduce these words to a common root so the computer understands they belong to the same concept. This avoids treating similar words as completely different. The final common step is part of speech tagging. Here, each word is labeled based on how it functions in the sentence. For example, choose is identified as a verb, while moon is identified as a noun. This helps the model understand how words relate to each other grammatically, not just as individual terms. All of these steps together transform raw text into structured data that machine can work with. And the most important thing to remember is that in most real applications, you don't have to perform these steps yourself. When you use managed services like Azure Language in Foundry, text preprocessing happens automatically behind the scene. As a user or the developer, you work with clean result, while the platform handles tokenization, normalization, cleanup, and tagging for you. Let's look at how text can be analyzed and how language models have evolved from simple statistical techniques to modern semantic models. At a high level, there are two main approaches: statistical text analysis and semantic language models. And let's start with the more traditional approach, statistical text analysis. Statistical text analysis is all about learning from counts. Statistical text analysis is based on a simple idea. Words that appears often tell us what a document is about. One common technique is term frequency, often called TF. This simply counts how many times each word appears in a document. For example, if a document contains the word AI, business, and customer many times, we can reasonably guess that the document is about AI and business value. This works well for a single document, but gets harder when we analyze many documents together. That's where TF, IDF, or term frequency and verse document frequency comes in. TF, IDF looks at how often a word appears in one document compared to how common it is across all documents. So a word that appears frequently in one document but rarely in other documents becomes more important. This helps differentiate documents that may share common language but focus on different topics. Another common statistical technique is bag of words. Here, word order and grammar are ignored, and only word frequency matters. For example, if a piece of text contains words like happy, great, and fantastic, the system may classify it as a positive sentiment. This approach is widely used for tasks like spam filtering and basic sentiment analysis. Another well-known statistical method is text rank. Text rank works by scoring sentences based on how similar they are to other sentences in the document. Sentences that share important words with many other sentences are considered more important. The top-ranked sentences are then extracted to form a summary. This technique is commonly used for extractive summarization, where the summary is made of the most relevant original sentences rather than newly generated text. Statistical techniques are simple and efficient, but they have a limitation. They count words. They don't truly understand meaning. Modern language models take a different approach. Instead of just counting words, semantic models represent words as numbers called vectors. These vectors capture meaning and context, not just frequency. You can imagine this as a map of meaning where each word is placed in a multidimensional space. Words with similar meaning are placed close to each other. For example, dog, cat, puppy, and kitten end up near each other, while words like tree or ball are much farther away. The computer doesn't understand animals or objects the way we do. but it learns these relationships from how words are used together in language. Now let's use the famous example. Here's the example that often sounds confusing, but actually isn't. Dog plus young equal puppy. This doesn't mean the computer is doing real math. What it really means is this: the word dog has a position on the meaning map. Young points in a direction that means a younger version. And when you move from dog in the young direction, you land near the word puppy. So the model learns that dog refers to an adult animal, and puppy refers to the younger version of that animal. The relationship between dog and puppy is captured numerically based on language patterns. This vector-based semantic approach is the foundation of modern large language models, or LLMs. LLMs don't just count words. They use embeddings and contextual attention to understand relationships between words, sentence, and ideas. That's why modern AI can interpret meaning, summarize accurately, answer questions, and generate language that feels natural and relevant. Now let's do a quick exercise where we will explore text analytics techniques to evaluate sentiment, identify key terms, recognize entities, and summarize texts. You can also practice this exercise by accessing the lab steps in the link that you can see on the screen, or by visiting the AI-901 learning path through the Microsoft Learn platform. Let's go! This exercise, we will use AI natural language processing functionality to analyze texts. So the goal of this exercise is just to explore common applications of text analysis techniques that we talked so far about them in the class. So for that, we're going to access aka.ms/chat-playground. You'll find the link in the exercise that is in our learning path for the AI-901 course. So for this, we will need a specific hardware set up in our machine. It's executed locally in the web browser. So the only thing that you need to have a modern browser on your computer. You will need to have also a sufficient hardware resources to actually download and run the model. We can run it on GPU with Phi-3 mini model, or you can still use CPU, but it's much slower than the GPU model with Phi-2 model. So all the specification for the hardware, you can find them in the exercise too. So let me here move to the dark mode, because I prefer the dark mode. So here you select the model, either Phi-3 or Phi-2. And here we're going to start, trying out things. So let's start first with sentiment analysis. So sentiment analysis, as we said, is a common NLP task. It is used to determine whether the text is positive, neutral, or negative sentiment, which is really make it really useful to recognize reviews, for example, on social media or posts and other objectives also. So I'm going to say analyze the following review and determine whether the sentiment is positive or negative. So here I stayed at the Hudson View Hotel in New York for 4 nights in November, and it exceeds every expectation. From the moment I arrived, the staff made the experience memorable. So overall, the Hudson View Hotel made my trip to New York feel effortless and enjoyable. So you can see here, I recognize here that this is positive, because I'm a human. I can understand a positive review. So if you look here, really, the sentiment of this review is positive. The reviewer expressed satisfaction with their stay at the Hudson View Hotel, mentioning that it exceeds expectation. This shows positiveness. memorable stuff, made the trip to New York great, and so enjoyable, and so all the things. So it gives you an idea of the sentiment. If we try this, what about this? For example, here I had a terrible stay at the Sunset Hotel, Palm Hotel. So you see, I had a terrible, check-in was slow, most of the staff seemed overwhelmed. So we feel here negativeness, right? So we see here the sentiment of this review is negative. Why? The reviewer had a poor experience at the Sunset Palms Hotel, mentioning slow check-in, uninterested staff, thin walls, unreliable Wi-Fi, and lack of cleanliness at all. Okay, let's try out something else. Let's try to do named entities, for example. So here, a list of places that I'm mentioning in the text, and I want to have named entities. So there is this text has some places, and you want it to name it for me. So I'm asking for specific things. So I want like places. So I can ask for other things like, can you give me all the named entities? But here's I'm looking for places. So let's look. Welcome to AI Tour. We are looking forward to seeing you in New York, Boston, Seattle, San Francisco in July. So I see it detected the 4 of them. Other thing we can do also in text analysis is summaries. So you can summarize text, right? So I can ask it to summarize for me a specific text. So here I have a long text. I'm going to ask it to summarize the following meeting transcript in single paragraph. As I said, you can also try out all this in your own computer. If you have the right setup, you just go to the learning path and get the lab steps. I'm going to practice exactly the same thing that I'm showing you in here. So you see here in the meeting, the team discussed potential off-site location. Let's look. And decides on Las Vegas, and also here we proposed initially Denver, Austin. You can see here, it's summarizing really the discussion that we have here in this meeting, that we can confirm if we read it, all the information there. Now let's try out a large language model or general purpose model. Let's try like specific thing, okay? So I'm going to use this specialized language analysis tool, which is the language app that you can find it at aka.ms/language-app. That is language playground that you can try out really many things from detecting language to identify PII in text and also other things. So you can see here we have a list, language detection and text PII extraction. So I can select here a sample, for example, a French paragraph. Bonjour, je m'appelle Sophie et j'habite à Lyon. Let's do to detect. So I see here it predicted French with some specific prediction confidence. Just remember that this is like things that is running locally, so it doesn't have like the perfect accuracy here. So I can try out something else here. This is a Spanish text. I can see here it detected also this is Spanish text. We have also here you can try out with, you click just to edit, you can try out also with other type of text here. So you can put this Arabic text and it detected it's Arabic with really high prediction confidence because the text is the word writing letters is so different in here. You can also here add a file and try it out with a full file, your own text that you pre-prepared already. You can do also text PII extraction also. So we have different here sample. For example, here we have a customer form. You can click detect from this customer form. You can see here detected a phone. This is a phone number, right? The person name, yeah, an email, yes, and an address. We can edit, try something else. For example, contract note. This is a contract note. Also, it detected all the information that we expected to detect it. I can also put my own text here. I can hit edit, and I can put my own text in here and hit the detect, again to detect the information. As you see here, a phone number, person, and an address. Yes, you can also grab these two tools, experiment, try out, and see what it's going to give you. So in this exercise, we explored the use of AI to analyze text using NLP functionality in a browser-based app. I hope you enjoyed this demo, and let's get back to class. In this session, we discussed how NLP enables computers to understand human text by combining preprocessing, analytical tasks, and modern language models. From basic word count methods to advanced semantic models that capture meaning and context for real-world scenarios. Remember that all this material is available for free on the Learning Path, and you can find the full Learning Path at the Microsoft Learn platform. This concludes our session. Thank you for joining us for this session. To continue your learning, we encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. Happy learning!